In this demo, I'll show you how to create a new class and how to use constructors, properties, methods, and accessors. I'm going to start this demo in the classes.ts file I created in the last module on interfaces. I gave you a brief preview of classes when I built this University Librarian class that implements the librarian interface. I'm going to begin here by adding a new class to the file named reference item. I'll give it two properties, title and year, to represent the year it was published. I'll also add a constructor to the class. Remember that constructors in TypeScript are actually named constructor. I won't include any parameters yet, and in the body I'll just log that a new reference item instance is being created so that we can observe when the constructor is actually being called. I've got properties and a constructor, so for the sake of completeness, I'll also add a method. I'll name it printItem and keep it very simple. No parameters and no return value. It will just log some information about the reference item. Since I'm obviously a fan of the humble console.log function, I think it's time I show off a feature added to ECMAScript 2015 that's also supported in TypeScript. They're called template strings, and they allow you to embed expressions in string literals, which I think is much nicer than concatenating lots of literals and variables together to get the output you want. Template strings are surrounded by a pair of backtick characters. I know they appear small here in my editor and look a lot like the single quote or apostrophe character, but it's actually the backtick. Within the template string, you can include expressions that will be evaluated and inserted into the final string. Expressions begin with the $sign and are then enclosed in curly braces. In this first expression, I'm beginning the string with the value in the title property of the object. In TypeScript, you must use the this keyword when referring to properties and methods in the same class. I then continue the string literal without any cumbersome concatenation and add another expression at the end to print the year. Okay, that's all I'll add to the printItem method for now. In order to use the reference item class elsewhere in the app, I need to export it from this module just like I exported the University Librarian class. I'll just add this class to the same export statement. Let's now jump over to the app.ts file. I need to import the new class from the classes file, so I'll just add it to the import statement I already have for that file. I'll go to the end of the file so I can write some code that uses the new class. I'll first declare a new variable named ref and assign it a new instance of the reference item class. You create new instances of a class by using the new keyword followed by the name of the class and any parameters expected by the constructor. I'm going to set the title and year properties and then call the printItem method. I'll start the build task and then press F5 to run the app. I get two messages in the console. The first is the message I logged inside the constructor, so we know that is when our object was being created, and the second is the result of calling the printItem method, which used the template string to output the title and year of the item. I'll return to the editor, and I'm now going to open the classes.ts file on the left side and app.ts on the right side. Remember that all class members are public by default. I'm going to explicitly make year private by adding the private keyword in front of it. Notice that when I do that, I immediately get an error in the app.ts file where I'm trying to assign a value to the year property. I'll hover over it and see that the error message is very clear. Property year is private and only accessible within class reference item. I want to implement these properties a little differently, so I'm going to delete these two lines of code that use them here. I want to pass the values they should contain to the constructor, so I'll modify it to accept two parameters named newTitle and newYear. I'll then assign those parameters to the properties inside the body of the constructor. If we now turn our attention back to the app.ts file on the right, we can see that I have a new error on the line that creates the new reference item. It says, supplied parameters do not match any signature of call target. That's a fancy way of saying I'm not passing the parameters expected by the constructor. It now expects a string and a number parameter. Each class can only have one constructor, but if we want some flexibility regarding what parameters we pass to it, we can always specify that the parameters are optional. I'll add a question mark after both of the parameters on the reference item constructor, and you can see that the error in app.ts goes away. In this case, I want them to be required, so I'm going to remove the question marks. I'll then pass a title and year to the constructor when I create the new instance. I'll run the app again and I get similar output but with the new title and year I used. I'll stop the debugger and close some of these extra windows. Since all I'm doing with the constructor parameters is assigning them to properties, I'm going to convert them to be parameter properties. I'll add the public keyword in front of the first parameter and rename it to be title. I want to keep year private, so I'll add the private keyword in front of it and change the name to year. I can now delete the two lines inside the constructor that set those values and the two property declarations inside the class. This is just a more concise form of what I had before. There will be a public property on the class named title and a private member named year, which is only accessible inside the class. I'll go back to app.ts and change the parameter values before running it again. While I'm here, I want to point out that classes, like interfaces, define types. I didn't initially add a type annotation to this ref variable. The TypeScript compiler inferred that it's of type reference item since that's what I assigned to it. However, just to prove I can use a class as a type, I'll add the annotation now. That works fine and I don't get any red squigglies. I'll run the app and it shows the updated title and year, so we know I implemented the parameter properties correctly. I want to add another property to the reference item class, but I want to implement this one with accessor functions. I'll start with a new private variable named _publisher. There's nothing significant about the underscore other than it differentiates the name of my backing variable from the name of my accessor functions, which will be publisher without the underscore. Getters begin with the get keyword followed by the new property name and an empty set of parentheses. Specifying a type is optional, but I'll add one. Inside the body of the getter, I can add any custom logic I need. I'm going to keep it very simple and just return the private backing variable converted to uppercase. I now need a setter. It begins with the set keyword and must take exactly one parameter. I'm specifying a type for that parameter, but you must not specify a type for the setter itself. The closing parentheses around the parameter is immediately followed by the curly braces surrounding the body. In the body, I'll just assign the new value to the backing variable, remembering that I must use the this keyword in front of all class members. Okay, the accessors have effectively created a new property on the class named publisher. Let's go back to app.ts and try to use it. You can see that when I type the dot after my variable name, the code completion help recognizes the new publisher property. I'll assign a string to it which will exercise the setter, and then I'll log the property to the console which will exercise the getter. I'll run it again and we can see that the assignment was obviously made correctly and that the logic inside the getter ran and returned the string in all uppercase. The last thing I want to quickly show you in this demo is how to add and use a static property. Back in the reference item class, I'll add a new static property named department and initialize it to research. It looks like any other property except for the static keyword in front of it. To see how using it is different from instance properties, I'm going to add a second log statement to the print item method. It uses another template string to log the value in the static property. Because it's a static property, it's only available on the class, not on instances of the class. I refer to instance properties inside the class by prefixing them with the this keyword. But the static property must be prefixed with the class name. Since our test code already calls the printItem method, I can just run this again to see the results. It does correctly log the department. Okay, time to move on to a discussion of inheritance and how to extend classes in TypeScript.